All right, so we're doing what are called the sum and difference formulas. First two, sine of u plus v equals sine u cosine v plus cosine u sine v. The sine of u minus v equals sine u cosine v minus cosine u sine v. Yes, you're good. Does anybody have the front and not the back? I accidentally did not get the back. You should have two sides. All right. All right. All right. You don't have to write this down if you don't want to, but when finding the sine of the sum and difference of two angles, you multiply the sine of one by the cosine of the other. The sine, SIGN, between the two is always the same as the sine of the original problem. So it's always sine, cosine, plus cosine, sine, or sine, cosine, cosine, sine. Now, if it's an addition, it's not going to matter if the addition is commutative. But you got to be careful of the subtraction. When it's subtraction, make sure you stay with the sine u cosine v first minus cosine v. Cosine of u plus v is cosine u cosine v minus sine u sine v. The sine of u minus v is cosine u cosine v plus cosine u sine v. When finding the cosine, you multiply the cosine of the two angles and the sines of the two angles together. The sine between the two is always the opposite of the sine of the original problem. So if you start with an addition, you are going to subtract. If you start with a subtraction, you are going to add. And then the last batch, tangent of u plus v equals tangent u plus tangent v over 1 minus tangent u tangent v. Tangent of u minus v is tangent u minus tangent v over 1 plus tangent u tangent v. The sign SIGN of the numerators is the same. The sign of the denominators is the opposite. All right. Yeah, a second. Oh, there we go.
Are we recording?
We are while it's time. You can barely hear a part unless you really can't hear too much, like when people ask questions. So it isn't why. Do you want to be recorded? You want to be? Okay. All right. So what they're going to do is they're going to give you sine, cosine, or tangent, but it's not going to be something traditional in unit circle. So it's not going to be in the 30 family, it's not going to be in the 45 family or the 60 family. Instead, it's going to be a combination of them, and you have a choice. All right, so cosine 75 degrees, you have to figure out which two angles that are in the unit circle, either add or subtract that. One possibility is cosine 75 equals cosine 45 plus cosine 30. So that's one possibility. It's not the only one. Okay? It's certainly not the only one. You could have the cosine of 135 minus the cosine of 60. All right? What you then do is take the formula, which you'll have the formulas when you take the quiz on this in front of you. All right? And you break it down into the parts. Cosine 45, cosine 30 minus sine 45 sine. All right, when you do tonight's homework, if you want to skip that part and go directly to that part, it's fine. All right, so this shows knowledge of that. So I would need to see one of those. Now the cosine of 45 is root 2 over 2. The cosine of 30 is root 3 over 2. Sine of 45 is root 2 over 2. The sine of 30 is 1/2.
Question. So I see that the top is like cosine, they go cosine, sine, and tangent. How do we know which one to use though out of the two cosine?
Depends on what you choose to pick in.
So if I wanted to do
So if you, like I said, if you had one, we're going to show you another one. Like if you did 135 minus 60, then you would use the minus 1 for the plus. And your answer, so it may be switched. You'll see like the numbers might be switched. So instead of like 1 plus 2 over 3, it might be 2 plus 1 over 3, but you'll get the same answer. All right, now you are going to multiply. So root 2 times root 3 is root 6. So that becomes root 6 over 4. All right? Root 2 times 1 is root 2, so that's root 2 over 4. You will notice those two denominators are exactly the same. So we can put them together. So our final answer would be root 6 minus root 2 over 4. All right. If you were to write it out, and unfortunately I have to format it this way so that it can get up in Google Classroom, but it would look like this. So that would look like root 2 over 2 times root 3 over 2 minus root 2 over 2 times 1a. So that's what it would look like if it was formatted. That would be root 6 over 4 minus root 2 over 4. And then you would see the two denominators are exactly the same. You'd have root 6 minus root 2 over 4.
Why are we able to do root 4 over 4?
You mean they're not the same. Square root of 6 minus the square root of 2 is not the square root of 4, you fool.
Like, I didn't know maybe like...
No! You can't. They have to be the same. If this was like 3 root 2, what?
He's like, God do that. I'm just asking questions.
And it's fine. And it's fine. Now, this is up to you if you want to jot this down or not. This is the same problem that I'm going to do to get to her point. That's the same problem with cosine 120 minus cosine 45. All right? So this answers your question. So this one's a minus, so instead of a plus 1, you would use minus. And you'll notice it comes out to negative root 2 plus root 6 over 4, which is the same thing, just a different way. So does that answer your question correctly? Yeah. See how good I am at what I do? Yeah. I even know what you're going to ask. Yeah. So you'll notice they come out to be the same.
Is there going to be a charger here?
All right. So now we're looking at sine of pi over 12. Now the book, if you use it as a reference, will show you it using pi over 3. I would not do that. For these problems, I would turn it into degrees. Remember, pi is 180. So pi over 12 equals 15 degrees. 180 divided by 12 is 15. So I would turn pi and 12 into 15. And we can rewrite 15 as 45 minus 30. But again, you can have 135 minus 120. There's different angles you can use.
Wait, it was just 180 divided by 12, right?
180. Just how, if it gives it to you in radians, just divide it by, just think of it as 180 divided. All right?
Yeah, we have to replace the power of 4 pi over 6.
Yeah, you can do it that way as well.
So how would I write it? I'm just like.
You would write sine of 45 minus 30. You can do it that way too. But this is just showing it if you want to do it in terms. All right. So that becomes sine of pi over 4 cosine pi over 6 minus cosine pi over 4 sine pi over 6. So again, you have the sine of the first angle times the cosine of the second angle minus the cosine of the first angle sine of the sine of pi over 4 is root 2 over 2. Cosine of pi over 6 is root 3 over 2. Cosine of pi over 4 is also root 2 over 2. Sine of pi over 6 is 1/2. You get root 6 over 4 minus root 2 over 4. If they have a common denominator, we write it as root 6 minus root 2 over 4. And you'll notice that answer and the answer to the previous problem are exactly the
Same.
That is because of cofunctions, the sine of one angle is cosine of 90 minus that angle. But you're also going to notice, ladies and gentlemen, that that's the format of every one you get. It's going to have a root 6, a root 2, and a 4 in the denominator, every single one. It's just going to be in a different order each time. Because one of these is always going to be in the pi over 4 family, which is why I showed you this as well. And one of them is always either going to be in the pi over 6 and the pi over 3 family. So you're always going to end up with a root 2 over 2 and a root 2 over 2, and either a root 3 over 2 or a 1/2. Every single time. You'll see when you get the homework. All the denominators. All right? So the main part of this isn't the answer, it's the work involved in getting it. Good with sine and cosine? All right, the trickier one's tangent. Dang it, I did it again. No presentation. Tangent. All right. Jen is very selfish.
I got lunch 4th period. Want to switch? Having breakfast.
I would love to have lunch later in the day, actually. I hate having my lunch. All right. What? You're not gonna what?
I was talking to John. He's not even listening. He's trying to play volleyball. I accidentally hit a part of my Apple Watch. The tiny little.
Chip. Wait, you have a car and your tiny little chip in your windshield becomes a crack. All right, tangent examples. The tangent of 75. Tangent of 75 is the tangent of 45 plus 30. If we plug it into our formula, it becomes tangent of 45 plus tangent of 30 over 1 minus tangent of 45 tangent. So we add their tangents on the top, we multiply them on the bottom and subtract it from 1. All right? The tangent of 45 is 1. The tangent of 30 is root 3 over 3. So we plug those in. What's up, Jim?
What is the multiplication? Is that multiplication sign on the top?
What, this?
Yeah.
No, that was just something I needed to keep the That means nothing. So that's not there. How's that? We'll do it that way. Hold on. Better?
No.
All right. So at the end of the day, we end up with 1 plus root 3 over 3 and 1 minus root 3 over 3. Now here's where things get a little tricky in working with the expression. 1 plus root 3 over 3 becomes 3 plus root 3 over 3. So that's that expression. 1 minus root 3 over 3 becomes 3 minus root 3 over 3. That's the denominator. So in other words, this goes back to rational expressions last year. We write the numerator and denominator with a common denominator. Make sense? So this numerator becomes this. This denominator becomes that. So I'm going to rewrite this like that, and that's the result. 3 plus root 3 over 3 minus root 3 over 3. You will then notice your two denominators are exactly the same. So when they do the division, those 3's will cancel out, and you're left with simply the numerators. That's the trickiest part of this whole unit. All right? Good thus far? Now what you're left to do is rationalize the denominator.
We're not done?
No. So you would now have to take 3 plus root 3, 3 minus root 3, so this gets moved to there. All right? And you multiply by the conjugate. That would be 3 plus root 3 times 3 plus root 3. When I multiply this out, I have 12 plus 6 root 3. When I multiply this one out, I got 6. 12 divided by 6 is 2. 6 divided by root 3 divided by 6 is root 3. Again, with tangents, all your problems are going to look like that when they're done.
Oh, the answer's up there.
Yep. The 2 plus root 3 on the top. Good. Okay, so what it looks like is one long problem. What it looks like is one long problem. Tangent of pi over 12 equals the tangent of 15 equals the tangent of 45 minus the tangent of 30. Oops, maybe I should actually show that to you. Huh? There you go. So that's what it looks like. All right. Everybody good with that? Okay. So this becomes the tangent of 45 minus the tangent of 30 over 1 plus tangent of 45 tangent of 30. All right. The tangent of 45 is 1. The tangent of 30 is root 3 over 3. Over 1 plus their product, which would be root 3 over 3. And that's going to happen each and every time. All right. As we said, 1 minus root 3 over 3 becomes 1 minus root 3 over 3. 1 plus root 3 over 3 becomes 1, 3. These should be 3s. Sorry. Those should be 3s. Slide that over. Everybody good with that part of it? And then what do the 3s do to each other in the denominators? Cancel out. So now you have 3 minus root 3 over 3 plus root 3. I want to work on that before college. All right. We look at your denominator and we multiply by the conjugate. That would be 3 minus root 3 times 3 minus root 3. Everybody understands what the conjugate is. We're then going to FOIL or distribute the top and the bottom. In the top, 3 times 3 is 9. 3 times negative root 3 is negative 3 root 3. 3 times negative root 3 is negative 3 root 3. And then root 3 times root 3 is root 9, which is not 3. A negative times a negative turns it into a positive. Over now. The purpose of the conjugate is the outers and the inners are going to cancel each other out. So I don't even need to worry about that times that and that times that. 3 times 3 is 9. Root 3 times root 3 is 3. The outers and inners are going to cancel each other out. You're then going to collect like terms. 9 plus 3 is 12. Minus 6 root 3 over 3. A 6. I should learn how to add and subtract.
Where do we get 6 root 3?
3 root 3 and a negative 3 root 3. They're both negative.
So why don't we just cancel it out?
They don't. They're both negative. One's got to be positive. One's got to be is a negative. I have a little drip on my pen.
Doesn't 2 negatives make a positive at some point? When you multiply?
Okay. You need to focus on sign number rules from, I'm not going to mock you here. Although it's going to certainly sound like it. 6th, 7th grade?
No, I struggled with the 7th grade.
Well, it's coming back to haunt you. 12 divided by 6 is 2. The 6 is canceled. I have 2 minus 1.
There is a multiplication. I'm so confused. Oh! Got it.
Take a moment. All right.
Everybody makes mistakes.
This is true. I didn't stop you from making it. As long as you realize what it was. All right. Now the last part of this part of the lesson. Evaluating trig functions of unit circles. All right. Now, here's the problem in the way it's set up. Find the sine of u plus v given the following. The sine of u is 4/5, and u is between 0 and pi over 2. Cosine of u is negative 12 over 13, and v is between pi over 2 and pi. Right? Now, that's drawn out what we're trying to do. All right? So this is u. They tell you u is between 0 and pi over 2, so it's in quadrant 1. In the homework, they'll tell you what quadrant it's in. So there's the 4 and there's the 5 representing the sine. You then use either Pythagorean theorem or triples to get your missing side. Same thing over here. They tell you v is in quadrant 2. There's the 12 for the adjacent, and there's the 13. Cosine of u is then 3 over 5. The sine of v is 5/3. Cosine of u is 3 over 5. The sine of v is 5/13. That is the only part of this that is new. All right, everybody get that part? Okay, so now if they want the sine of u plus v, all right, sine of u plus v equals sine u cosine v plus cosine u sine v. The sine u given you is 4 over 5. The cosine of v given you is negative 12 over 13 plus the cosine of u, which you found was 5 over 13. The sine of v, which you found is 3 over 5. You're now just multiplying fractions. 4 times negative 12 is a negative 48. 5 times 13 is 65. 5 times 3 is 15. 15 over 65. Negative 48 plus 15 is negative 33. The final answer is negative 3 over 65. These two denominators should always be the same. And then it's very straightforward. You're just adding the numerator. Yep. Negative 33 over 65. That's all it is. And you're done. Good? All right, so to finish up for today, you do the last one. Yep, find the cosine of u plus v given sine of u equals 12 over 13, and u is between 0 and pi over 2. Cosine v is negative 3/5, and v is between pi over 2 and pi.
You don't have to do anything with the triangle.
You don't have to, you just use it to find the other value. You know what I mean?
Yeah.
So the triangle just shows you where the number comes from. This sheet that I'm putting on all your desks is the homework corresponding to today's lesson. It is due Wednesday at midnight. Yep. You will notice all of them have the same denominator, 12. All right. Duplicate. And you end up with negative 63 over 65. All right. Everybody got it? Real quick, I just want to go over a couple things. Number one, all right, is number 7, cosine of negative 7 pi over 12. That gives you negative 105. There's nothing wrong with it. All you have to do is pick two angles that subtract to 105 and then flip their roles. So in other words, 105 is 105 minus 135 minus 30. So basically all you would do is the cosine of 30 minus 135. Other than that, it's exactly the same. Okay? The second thing is, if you want the edge elastic quiz tomorrow, there will be additional time for you to take it because some of the problems are a little time consuming in terms of entering things. Please, as directed in Google Classroom, make sure you watch the video so you enter things correctly. If you have an issue, log in to the live stream and write it there because I can't follow Google Classroom and the live stream at the same time. So if you log into Google, if you log into the live stream and ask the question there, I can address it right away while class is going on.
You do the sign there with the points thing if you watch the video.
Yeah.
So do we have to, it says like with edge elastic, do we have to go into edge elastic and that 3?
No, you just have to watch the video.
Oh, I didn't.
If you go in edge elastic and do it, it's fine. I just open that up for people to practice.
Okay.
But this was a way to get people to watch it and give them a point value for it. Because the quiz doesn't come out to a set number of points. Like it comes out to like 67 or whatever.
Okay.
So by watching the video, I can just put 3 points on it and it adds 3. You know what I mean?
Okay.
So if you got like a 60 out of 67, it would bump you up to a 63 out of 70.
Okay.
And if you don't do it, then you lose those
I
3
watched
points.
the video and I was like, oh wait.
Yeah, you can do the other ones though if you want to practice it. The edge elastic that's up there because I posted that the other day. But I didn't want to make it like an assignment for people to do to get it to make sure they did it. So I wanted them to watch it. Yeah. All right. So I can stop recording.